The regulatory side of things, again, the spectrum is a shared resource, and in Canada, Industry Canada regulates the use of who gets to do what with the spectrum. They put caps on the amount of power that you can have. They basically dedicate a number of bands for what they call unlicensed operation, which means you can just buy a radio and you go ahead and use it. The problem is anybody else can buy a radio and go ahead and use it in the same area. And that can cause some problems if you're relying on that system to work. They've set aside other bands for different applications. There's one that we deal with a fair bit, is the land mobile radio spectrum. And so for mobile applications, they have spectrum at 200 megs, 400 megs, and 600 megs, 900 megs, and up, where you can get a license, you pay for that license, and once you've paid for that license, you basically own that spectrum in that area. That keeps other people out of it in theory and allows you to have a bit more control over it. Generally speaking, you can have more power in those applications as well, and so if you want longer range, that's often a good way to go. If you're designing a product which has to go outside of North America, or outside of Canada and the US are quite well harmonized in terms of the availability of the spectrum and the regulations for both. But outside of that, it's sort of all over the place, and there's only a few bits of spectrum which are pretty much international. So if you are going international, you're going to want to look at the availability of spectrum in the countries where you're going to sell, and then design it around there. Of course, if you're designing something, and you have to know how much it's going to cost to see whether it makes business sense. There's going to be upfront costs that you have to take care of, the development of the technology. Anything that's going to be radio-based is going to have to be certified to make sure that it doesn't sort of infringe on other people's use of the spectrum. There's a cost associated with that. There's going to be a cost with actually manufacturing the parts, installing them in the field, going ahead with all that kind of thing. There's going to be operating costs, and they can range from the actual cost of the fuel and the energy required to make it work, maintenance costs, but they also can be spectrum access costs in some cases where you have to pay an ongoing rate, especially if you're using something like a cellular modem, where you have to pay the cellular companies to access it. Disposal costs are an issue in Europe right now, where if you have to pay up front to have it recycled at the end of it, and cost of failure. If you have a system where you're depending on it to work, if it doesn't work, there's going to be a cost associated with that. If it's a remote site and you have to send a helicopter out at $2,000 an hour, you don't want it to fail every 5 minutes because it gets expensive for you. Some of the off-the-shelf wireless technologies that we've dealt with that people have used are, Bluetooth, Zigbee, Wi-Fi, cellular. There's a bunch of proprietary ones. A lot of these work in the 2.4 gigahertz unlicensed band. The reason that they're readily available is because it's unlicensed and anybody can buy them without having to get go to Industry Canada or FCC and get a license. They're great for what they do. They're fairly low cost. They're very well developed. They do have definitely some limitations. Bluetooth, we don't see a lot of that just because it's really geared for consumer products. The Zigbee stuff is coming along quite nicely, and it's really geared for industrial applications where you have low power, sporadic information going back and forth, control systems, that kind of thing. There's a latency issue. If you want to have things happen now, Zigbee isn't very good because it just takes a long time for it to work its way to the end position. But if you're willing to live with a couple of seconds delay, it works quite well. There's lots of Wi-Fi stuff available out there right now in different versions and different flavors. But again, you're getting a couple hundred meters, maybe a kilometer out of it, and with directional antennas. Cellular is great if you have cellular coverage. You can get quite high data rates through it right now. But if you buy a cellular modem, you're going to be paying the cellular operator a $5 to $10 a month fee just to be able to sit there and may or may not use it. And there's quite a few proprietary off-the-shelf solutions available. If none of those fit the bill, then we can look at doing a custom solution. And that's really what we do as Microlinks. We design custom solutions for people. And it can give you something which other people don't have, and that can give you an advantage in the marketplace. It gives you the opportunity to trade off performance versus cost and other attributes, right? You can say, I want to have something which is really specialized to do this. None of the off-the-shelf things do it, but I can really make it work well. Sometimes you can take an existing protocol like Zigbee or Wi-Fi and change it a little bit and get the benefits of the economies of scale that people have already invested in that technology, and still get the benefits of a custom solution. And really, you can look anywhere from hundreds of thousands, $100,000 to millions of dollars invested to get a technology solution that works for you. Obviously, you're not going to do the $1 million solution for a one-off type system unless it's going to the moon or something like that. Some of the applications that we've worked on are we worked on a seismic data gathering system for a company here in Calgary. They wanted to replace a lot of their cable with radio. And when you're doing a seismic shoot, you put out miles and miles and miles of cable. If you have to go over raging rivers and hard terrain like that, or even freeways, one of the things we dealt with was down in the States. You have to run a shoot on either side of a freeway. You can't run cable over the freeway. So that was a big issue for them. The other big issue was knowing exactly when to start recording data. So the time accuracy was super critical for them. And they had to go, they have to go many tens of kilometers in terms of range of covering all this stuff. So all those things led us to a 200 megahertz UHF licensed application where they controlled the spectrum. It fell sort of outside the letter of the regulations, and we had to actually hit up FCC and Industry Canada to get a waiver to allow them to use it, but they were able to do that. And we got a very spectrum efficient modulation scheme that allowed them to get about 500 kilobits per second through 3 RF channels, 3 radio channels. And so they were able to put that in place and actually get some good feedback from that. That company just got bought out recently, and the new owners haven't quite decided what they're going to be doing with it yet. So I think it's still a little bit on the shelf. Another one we have is a real-time sensor application. This is actually for use on a crane, where they have a load sensor at the end of the crane giving information back to the operator of the crane. And people don't want to be changing batteries at the end of the crane all the time. So this had to be sitting there for 10 years was the goal, to provide accurate A to D measurements on the end of the crane as to what the load was, wind loading as well as load loading, and providing that information to the operator. In this case, the applications were very low data rate, but super low power consumption, and also extended temperature was a big issue for them. This one was an unlicensed link that we used. The 900 megahertz spectrum is different in Canada than it is in Europe, so we have to make some slight modifications to make it work in Europe, but we could do that. Another one, which is not related really to the oil and gas industry at all, but it has some applications potentially, is a wireless sort of a competitor to Alarm Force, the alarm company. Alarm Force uses cellular modems, and that's great. It's a very cost-sensitive application. Alarm Force has to pay about $5 per subscriber to the customer, to the cellular operators, to have the modem in place. And if you have thousands of subscribers who are paying $29 each, that sort of ends up being a fair chunk of your money. This company decided to do their own RF stuff. We did a low-cost solution for them in the 470 megahertz. But again, it's very robust, and it had some unique challenges for them that really gave them a cost advantage on that one. Okay, thank you. I'm just done here. So really that's good timing. So the big question is, if you have to get data from point A to point B and you don't have control over it, wireless is a good way of going about it. Then you have to decide what the best one is. And again, if an off-the-shelf solution works for you, great. If not, there are custom opportunities, and there's a number of people around that can help you out with that. And that's really all I have to say. So if you have any questions, I'd be happy to answer them.